I have office hours 10 to 11, but I have to leave at 10:30 and have to go take my husband to the doctor. Only today. Only today, which is really close to you. Okay. So on Monday, I usually don't have office hours at 10, and I will, but only for this class. Count one don't need to know about it. Okay? I also have office hours in the afternoon on Mondays. If you have a last minute, it's like we talked about this in class and I still don't get it, you've gotta clean it up before the test. Don't plan on being lucky. I was always unlucky at the test. The one thing I didn't want to be there, it was always there. I was never lucky. So you have to sort of plan in ahead. Okay, so let's integrate 0 to 2, 1 over x plus 1 dx. Let me know what you get. So that would be part A. Integrate. Who's doing U sub? Who says that's linear? I don't want to. It's faster. What's the end derivative of 1 over x? Natural log of x. So if it's 1 over x plus 1, what should it be? Yeah, and then you check, because if there's a coefficient, you have to fix it up. But you can fix up constants. It's called the constant multiple rule. Okay? So it should be ln of x plus 1. It's that quick and dirty if the thing is just a linear change from x. You say, I'll pretend it's the regular and see how it goes. I heard the absolute values even though you didn't say them out loud. Does it check? Derivative log of stuff is 1 over the stuff, derivative the inside derivative is 1. From 0 to 2, what do you get? Natural log of 3 minus natural log of 1, which is well known to be. And if you don't know, you plug in. It's like, I think that's a special one. Check. So the answer is ln of 3. So this area is an estimating this area is an estimation of what this number is. And that's where you're too young. But back in the day, the back of all the math books had tables of trig values and log values. And this is how they were found back in the day. Now it's hardwired into your calculator. Both trigs and logs, and then it uses log properties and sine of a sum properties to get the other values. So how many trapezoids do you want? 5? 5. Let's use 5 trapezoids. Okay? So there is always the art part of the question. It says sketch 5 trapezoids. So how do you start that? Only I had the formula. Formulas on another one. Let me put the other one up so you can see it without having to flip back and forth. It says T is this. You need the delta x to get started. Okay, and I can't even draw them without the delta x. How big is delta x? Well, don't do it in your head, because if you make an error, I have no partial credit for you. Delta x is b minus a divided up into the number of pieces you want. Sorry.
Wait.
0. That was swaying me. So that's 0.4. Everybody agrees it's 0.4? Your calculator knows. It's really great. Okay. Now, here are the markers. 0, 0.4, 0.8, 1.2, 1.6, and 2. And you know you've got your delta x right if it starts at the beginning and ends at the end. Okay? If you hang over or you didn't get there, it's like, whoops, I calculated wrong. So you actually have a built-in chop. Now you just got to build some trapezoids. So, ooh, that's a little wavy. I have a lot of sympathy for motor control when you're sketching. Just be definite about it, and I will take it. Let me get my fat pen so we can see the whole trapezoid. Ooh, I like it very much. So there's one. On the scale of my graph, it looks like the trapezoid is a darn good match to the curve, yeah?
Mhm.
So then my trapezoid. Art for points, it's really great. Yeah, we'll bring colored pens, remind me on Tuesday, where are the colored pens? Oh, I have a bunch of them. That's fine. Okay, now we gotta do T. So here's the formula, and it will just be sitting there on your test. Okay, here's the formula. T is delta x over 2, and then you need a bunch of y coordinates. And so some people guesstimate off the graph. Is that a good plan? No, you have the name of the function. And the only time you estimate off a graph is if you don't have other intel. I know the name of the function. So some people like to label here. And some people like to do a table of values. Doesn't matter how you do it. The x's start at 0. 8, 2, 6, and end at 2. And then the y's come from the function. I can't write numbers and talk at the same time, so 1 over 2 this one. I didn't massage it all, because I'm just gonna throw that all into the list in my calculator. And I'm gonna write one line, and let my calculator do all the massaging, and it'll toggle into a fraction even. So there's no reason to clean that up. It's just along the way. Some people like it better over here. This is 0.8 and 1 over 0.8 plus 1. Is it clear out of the y coordinates?
Mhm.
Okay. It's taken a while, yeah? So this problem is where, I don't remember, 16 to 20 points, it's worth a lot. There is no big thinking going on here. It would be a shame not to get these points, okay? But I have to give points for how long it takes to do. So did I? I'm falling apart. Oh, I lost my mouse, which is telling me to put it on. Don't tell my calculus class. They're the vectors, right? You know freshmen. Don't infect anybody. Okay, tell me the formula. What goes in the front? Yep, so you take your 0.4, write it over 2, and then you write all the y coordinates, and you have to double the middle ones. 1 over 1 plus 2 times 1 over 0.2 plus 1 plus 2. I hope yours is neater than mine. 1 over 0.4 plus 1 plus 2. 1 over 0.8 plus 1 plus 2. 1 over 1.2 plus 1 plus 2. 1 over 1.6 plus 1 plus 1 over 3. And we don't double the ends. You have to remember not to double the ends. Now when I'm typing in my calculator, I'm not gonna write 2 and 1. I don't have that much time. What's going on today? Is everybody sleeping late?
I can't speak for the rest of them, but yeah.
It's the day. Don't do that on Tuesday. It's just handing minutes back, right? You don't get them back at the end. All right, so bravely put it in your calculator. See how you do. A lot of parentheses. Oh, if you want to write that whole denominator as 0.2 plus 1 in your calculator, you need parentheses. I don't want to. I'm going to write 1.2. I can add that in my head. 1.4. 1.8. 2.2. 2.6. Let's see if it toggles. many decimal places, it won't toggle to get me a fraction. Too many decimal places. When there are only like 4 trapezoids, it'll handle it. It'll give you a fraction back, which is really cool.
So is this the trapezoid rule? Is that what we're
Yeah,
doing?
it's
Okay.
called T for trapezoids.
Okay.
Okay. If I was doing S for Simpsons, it's the same work, except I can't do 5. Because you need 3 data points, which means I need an even number. I need the first 3, and then I need the second 3, which is 2 more, and so on. So you have to use an even number to do Simpson, which is parameters,
Why is the number of trapezoids 5?
because I picked it.
Okay.
Somebody has to pick, which is another question, which we're about to hit. Veggie.
As far as the X values, is there a reason like how they're like increments like that? It looks like that versus increasing like.
It increases by delta X. You start where you start, good question, and you go by delta X. So I start at 0, and then I go by delta X, which is supposed to be 0.4. Oh,
And you got an extra trapezoid.
because I've got, it's all wrong. Try again. Thanks, Deji. Speak up sooner,
I
say,
think it's
you
fine.
have the wrong delta X.
You should take.
Oh, it's just this guy?
Just take off that one.
Oh, thank goodness. Thank goodness. Okay, so I'm just gonna take away now. I've gotta retype this line of stack. Cause I know ln of 3 is 1.10 something. It's like, that was pretty grossly wrong. I should have known that. Is she a little bit tired? A little bit. 1/4 divided by 2. Here. 1/4 divided by 2 times 1 plus, do it again, 2 over 1.4 plus 2 over 1.8 plus 2 over 2.2 plus 2 over 2.6 plus 1 over 3. Oh, that looks much better, much closer to ln. So the badness here is I had 1, 2, 3, 4, 5, 6, 7 numbers, which is 1 too many, yeah? If I'm going from 0 to 5, that's 6 numbers, yes? So I should have spotted it early. Thanks, Deji. Does he get a roundup point for that?
Yes.
Yes.
Okay. I have to write it down. Put it on this one. I'm the break. That's one roundup. Okay, so yes, 5. Somebody chooses, that's not how it's done. Okay? You actually say, how accurate do you want it, and it will decide how many n to use. Now, in the modern era, your calculators are terrible. They just keep going. I say, okay, let's use 10, now let's use 100, now let's use 200, and they just keep checking to see if the places it's showing are accurate, are changing or not. And then it stops when the display doesn't change. Of course, that doesn't mean down the road, the thing that's changing down in, it's this place for you, doesn't roll over, which would cause the next one to roll over, which would cause the next one to roll over. So this is bogus coding. It's not good. But if you're building a rocket or an automobile or a bridge, you have to actually know what error is allowed and choose accordingly. Not, it looked okay. I actually went to a meeting one time and I said, I put an upside down e the x curve on it because that's what it looked like. But no, that's not how it's done. You estimate the error and then fit accordingly. So that's what's done for this kind of work, and that's what this other formula is. It's this, okay? It says here's an estimate of the error, and why is it an estimate? It says less or equal to. If you knew it exactly, you wouldn't do this work. Okay? So it's bogus to do ln of 3 because we already know the answer. So if I want to know how wrong I am, I would take my number and subtract answer minus ln of 3. And and this tells me how wrong I am. I'm 0.011 away from the actual answer. But that, if I know it exactly, I don't approximate, I do exact. So this is really for the integrals we looked at yesterday, where you're trying to estimate the number of primes, and you have an integral that can't be done. Or you want to integrate sine of x squared, where you don't have any du. You just have to do something numeric instead. That's when it actually gets used. And then you need to know how good your answer is. And so the best you can say is an approximation of the error. This is the actual error, which is what I just did, subtract. But to estimate it, you can estimate it with this formula, which uses the maximum of the second derivative. It's actually 100% equal at some c in the domain. What was the theorem from Calc 1 that said you get something about derivatives at some c? What theorem was that? It goes by its initials.
Does it mean value?
Yeah. The mean value theorem says stuff is achieved, average rate and instantaneous rate coincide someplace in the domain. And so the error will be 100% met at some c in the domain using this formula. So we don't know where that c is, so you take the biggest, the grossest wrong it could be. And the reason it's an absolute value is I don't care whether I'm too high or too low. Okay? One would be negative error, one would be positive error. So you're absolute valuing the second derivative. Okay? And looking at the biggest it can be, and putting that here, and then you're using your domain, and you're using your number of trapezoids. And that gives you an estimate of how wrong your answer is. So let's try it on this guy. See if I can do better than this one. So I don't like tables much. I get a little paranoid. I do want to say there is a table option in your calculator. See this button? The trouble with it is that it always displays 3 places, which means if you're adding those up, you're compounding all your error. So it's not accurate enough for us. If you're doing baby work, it's fine, but for this kind of work where it's all about all these places, it's not accurate enough. So that's why I haven't shown you how to do that. So let's look at ET. So I have the delta x at 0.4, the B and the A. The A is 0, the B is 2, the N was 5. And what else do I need in the formula? So I need M. So last we're going to go to M, 12, no, B minus A, 2 minus 0, cubed, or 12 times 5 squared. And then I have to find M, which is the max of the second derivative. Okay, so my function was what? What's the formula, right? This is the function. What's f prime? Be careful, I want the derivative. Okay, you have to be really careful now that we know forwards and backwards. Can you tell I'm drilling Calc 1? Gotta know your derivatives,
Negative 1 over x plus 1 squared.
Right, and I'm just gonna use the power rule because I know I need another derivative. Ben massaged in his head, it's like the square in the denominator. It's like, I gotta take another derivative. You gotta think about the negative exponent again, so I didn't bother. So what's the second derivative? Oh, we did the chain rule, derivative the inside is 1. We did the chain. What's the second derivative? X plus 1 to the minus 3. Yeah. Derivative the inside is 1. Now I'm gonna look at it. 2 over x plus 1 cubed. And now you need to max that. So you need to think about some calculus ideas about the graph of the second derivative. What does this function look like? Sorta. And increasing or decreasing? Got a 50-50 shot here. Is graph going up or going down? Yeah, it's going down, right? The bigger the x gets, the bigger the denominator gets, which means the value gets smaller. So this is a nice monotone function. So where's the max?
0.
At 0. And usually the max is at the endpoint. It's like, well, let's see what happens at 0 and what happens at 2. Oh, 0 is the big guy. Okay. So what's the maximum value for that?
2.
2, plugging in 0. So that's the 2. So you put a 2 here. Now a slide for this is you have Desmos in front of you while you're working the problems to look at the graph and say, I see where the max is. You have to keep in mind, I just want to know the maximum value in absolute value. Up here, if this is further down, I'm going to take this number in absolute value. Because that's just talking about whether your estimate is too big or too small. So what do we get? 2 cubed over 12 times 5 squared. ET is less than or equal to 2 to the 4th over 12 times 25. I don't know what that number is. No. Let's look at that. Don't forget the parentheses over your, around your 12 times 25. Unless you did it in your head, that's 300. Equals 0.053, and I'm going to stop there, so I'm going to put an approximate on there. Let's see what ln of 3 is. 1.0986. Okay, so I had an estimate of 0.05, and I'm actually better than that. I'm 0.01 away. So it's always just an estimate of the error. It's very number crunchy, yes? Some people love this, okay? May I be your coach again? You have to write down the pieces you're putting in. Because if you write this down and you've done something goofy in your calculator, nobody can see it. Okay? So show your setup. I took numerical analysis, which is the 3000 level course, and I always wrote down my setup, and then I wrote down what I got, and every time not what I get. I could not do this part. I could set it up, but oh man, I was bad at it. So you have to help yourself out. Because it's a minor error. If you show me you know what numbers to put in and you just can't do this, I am not worrying about it. Minus a half. It's not a big deal. We just know we don't let you near the buttons. Just like Homer. Don't let him near the buttons. Oops. Right? Everybody knows who Homer is, right? Just checking. I know it's an old cartoon.
Dr. T, I have a question, sorry. How did you know when to go from like less than or equal to like the approximate?
Okay, so the whole point is it's this. This is actually equal. Good question.
Oh, okay.
Okay. This is this, right? But this is less than that because I took the grossest error I could with M. Really good question.
Okay,
Now, if I didn't know this and I said, I'm just going to use 5, I can say, and I'm about at most this wrong. And that's the point of the inequality. I'm actually less wrong than that. I'm 0.01 away. But you can actually say with some certainty, I'm at most this wrong. And that's still not how it's done. They say, okay, here's how accurate I want to be. And that's the last question in the homework, so let's look at it. Who coded the last question in the homework? Dr. T. So slow to get.
Dr. T, do you have an extra one of the handouts with you?
Yeah,
May I have one?
yeah. Oh, Trina saved you one, but she's not here.
Well, she actually sent me the practice worksheet.
Oh, she
and I
didn't save you this one.
No, she didn't grab the handout, and so I was like, where's mine?
Where are all these pictures coming from? And the important thing to know is that the formula, come on. This formula is sitting on the test, just like that. You have to know who A, B, and F are for your function, how to get Y, how to get your X's, okay? It'll be sitting there. You have to interface with this formula before the test, or you're gonna be not good job. So you need to actually have played with this. So let's go to 2260. have all these courses because I created the courses. And so I'm still there in case there's a problem, I can go fix it. Oh, look, right after the test, we're doing 3.1. So on Wednesday night, you will read before class for Thursday. Okay, so we keep encountering 1 over t or 1 over x plus 1. The answer to that one is ln of 3, right? And you drew 1 over is ln, and you plug in 1, and you plug in 3, and you get ln of 3. Is that the one we're doing? No, we're doing ln of 5, this one. No, we're doing ln of 3, yes, so we're in the same guy. Oh, no left standing. Sorry, I always forget. Come back. Want to be notified, thank you. Okay, it says use the error estimate for the trapezoidal approximation to determine the minimum number of trapezoids to approximate this integral to within triple O1. We got O1 with 5, it was pretty good. We estimated 0.05. Can we figure out what it would take to be sure that we're within triple O1? And this is actually how it's done. Somebody hands you a task in engineering, you say, how good do you want it? Because you can design different solutions depending upon the accuracy that's necessary. And you bill accordingly, right? It's like you want the souped up fancy one, it costs more than the one where it's like, I just did this 1 page of calculus and I won't tell you that, but here's the easy solution, that'll be $100,000. The really great one is $1 million. Yes, they do charge like you wouldn't believe. Oh, my husband got his hospital bill. 3 night stay, what do you think they billed it at? Before insurance. 3 nights? 87,000.
Oh, wow.
It's like $6 for an aspirin.
Over 3 nights.
Is it 3? It was a hellish time. Maybe it was 5 nights. Still a lot. 5 nights. Yeah, it's a lot of money. And then insurance takes it down to 14,000. I firmly believe in national health insurance, but you know, then I would have to wait in line to get my insulin. So it's still bad. There's no good way to be treated. We have good medicine, it's just really expensive. Okay, this is not the surgery bill. We haven't seen that one yet. So it says, by the way, thank you very much. Y'all pay taxes, right? Thank you. He's on Medicare because he's older than me. Thank you. You don't pay for his surgery. Use error estimate for trapezoidal approximation to determine the minimum number of trapezoids. Okay, so I'm going to put this up so I can write on the board. And I want N so that ET is less than or equal to 0.001. 0.001. The correct presentation is in print in WebAssign. They say 0 point, and the only reason I don't have it there is I have a really hard time counting lots of zeros. And so if the lead one is there, I accidentally count him sometimes. It's presented properly on tests and things like that. It's just my ability to read what's there. Oops. Okay. So I have f of x is 1 over x, and a is 1, and b is 3, and I want to solve for n this time. And your numbers would change. You get a different one here. So you get a different n. Okay, so the formula for ET is less than or equal to mb minus a cubed over 12n squared. No, you don't have to memorize it. It's sitting there on the paper. It comes for free. You have to do the work. I only know this formula when I'm teaching it. The rest of the time it's like, yeah, I think there's a cube in there, but I don't remember for sure. So look them up properly. So I know the A and the B. This is 3 and 1. This is what I want to solve for. And they told me ET. Now you don't want to put ET over here. You don't want to put 0001 here. And let's think about what. Do you want your error to be less than this number, or do you want your estimate to be less than the error? You actually want it to be over here, so that I know for sure my error isn't any bigger. But that really bugs people's brains, so let me be coached. The way I find success for students is set it equal and solve for n, and then you'll be fine, you'll know what to do. Okay? So we're just gonna set this formula equal, and then we'll get it right. Okay? If you set your error to be less than the error estimate, then you don't know if your n is big enough. It doesn't work out properly. So the only piece I need is this m. Here's f of x, what's f double prime? So we just did its neighbor, so you should know the answer. Take a derivative again. This is the minus 1 power, right? What's the second derivative?
X to the negative 2 times 1 over 2.
Try again. Can you skip this step ever? Nope. Okay. And he tried to do it in his head and it gets all messed up, yeah? So you have to write it down every time. Also, if you slap it down and it's wrong, I don't know what's wrong, and I can't give you partial credit. If you slap down and say, I see what you did, and the next one was okay, there's partial credit there. So you can't skip. I'm trying in my head, it's like, is it plus? Is it minus? I don't know. Even I don't know. Okay? You have to go one step at a time. So how big can this be on this domain 1 to 3? Well, what is it at 1? Two. What is it at 3? Yeah, it is. She's not afraid of negative exponents. Good job. It means 1 over, right? This is 2 over x cubed. This is really great for calculus, for thinking about numbers. This is really great, right? So you have to go back and forth in your thinking. Oh, I want to do calculus, let me write negative exponents. Oh, I want to plug in, let me write it as a fraction. It doesn't magically work in your head. You have to actually use the piece that works. And we're going to do some tough limits at the end of unit 2, and that coaching comes right back. It's like, oh, we integrated, we got a negative exponent, now we got to do a limit, let's write it as the fraction. So these techniques keep coming back. They're not unique to numeric integration. Okay. What's the biggest this can be on 1 to 3? The second derivative. Yeah. I'm cubing in the denominator. As the x gets bigger, the denominator gets bigger and the fraction gets smaller. Okay. And we can see that happening. So this is 2. So I have 2 times 2 cubed over 12n squared is 0001. Solve. Everybody has different algebra things they like to do when the variable they want is in the denominator. Some people immediately reciprocate both sides, and that's why it's good to solve the equality, because if it's an inequality, things keep turning around when you reciprocate.
Why is M2?
I need this is the max of the second derivative. I'm on this domain. The values decrease from 2 down.
Yeah.
So it's really helpful to look at both endpoints and say, yeah, I think it's this endpoint. Good questions. Who likes doing this? It's very number crunchy for me. It doesn't float my boat. Who likes this? Somebody's like, oh, it's kind of great. Okay, so what did you do? Some people multiply both sides by n squared first and then divide by 0001. Some people flip both sides of the equation. Doesn't matter, both work. This is 2, 4, 8, 16 over 12 equals 0001 n squared. So n squared is 16 divided by 12 times 0001. So you take the square root. What do you get? Approximately.
Plus or minus 0.155.
No. This is a really big number. Divided by 0001. Just multiply by 1,000.
115.47.
150 okay. Thought it was 3 places before?
115.470470.
So show all your steps. Your common sense should say, yeah, I don't think one trapezoid's gonna work, right? And it's like, well, I've got an error in there. I think you multiplied instead of divided.
Yeah.
Just like I multiply both sides by n squared to get to here, I divide both sides by 0001 to get to here. So, what are we gonna do with this number?
Not have like a decimal or a fraction.
Right, it's like, what is 0.47 trapezoids? It's like shave a little bit off? No. What? How many are you gonna use to be sure to guarantee?
116.
You have to go up. It's called the ceiling function in computer science. It's called the greatest integer function in math, but it's a terrible name. Ceiling function is much better. It says round up to the nearest integer. You have to, because you can't use a piece of a trapezoid. And if I go down to 115, it's not enough to make this guarantee I've just made. It might be enough because this is a gross guarantee, picking all of 2, right? When this number is so wimpy small by comparison. It might be enough, but you have no guarantee. So you have to go all the way up, right on. So let's use 116 trapezoids. And I think the instructions in the problem, since I wrote it, says your answer should be a whole number of trapezoids. Because it doesn't make sense to use a piece of one. And that's how it actually gets used. How accurate do you want it? I'll figure out how many I need based on my estimate of the derivatives, and then I will use that number. Now, of course, even in coding, they're not gonna use 116, they're gonna round up to 200, right? It's like, that's probably how they're gonna code it. But you know for sure it's accurate enough. And that's how it gets used. It's really fascinating to me. Now, the error formula for Simpson uses a higher power here, but a much higher power here. And so that shows you that it's more accurate to use the parabolic fit. The difficulty with that is you have to have an even number. Okay, you can't build it otherwise. And the other problem, so if you have data, it's like, please be an even number of data points, because otherwise I can't use it. You can't go in the middle if you have data.
And that's n that needs to be even?
Yeah. Yeah. Let's look at the formula again. Just make sure it's clear where it is on the formula. I find this quite interesting. I just don't like doing the table of values and all that crunching. The stuff is interesting, it's like, don't make me do it. I have to pull this plug or it gets really excited about my computer being here. It does say .cam, but it got excited. Come on. So here's the formula. And for, so yeah, and Arian just got his copy. There's a one typo on my page. It's ES, of course, because this is talking about S, Simpson. So if I know all the pieces, I can solve for N. If I know N, then I can solve for error. Does that answer your question, hon?
Yeah.
Okay. Who likes it? Nobody. Very good. Micah likes it.
For the substance rule, when you draw it, instead of drawing the trapezoids for the parabolas,
Yeah, so
how do you do that?
it's real, I like your question very much. It's almost always trapezoid on the test and they're proud of it. So here, I can't do 5, so let's do 4. So what's delta x? Minus 0 divided by 4 is 0.5, yes. Okay, so I go here, and I go here, and I go here, and I go here. So you take 3 points, and you fit a parabola, and it looks like that. So this is the first piece. You use 3 whole points. And then you take the next 3 points, which includes this one being used again, and you fit a parabola there. And you take that one. Nice question, I really enjoyed that. Pretty sure students can't draw that from me. But that's why you need an even number, because you need 3 points, and then you need 3 more points, which is the first and the last, and odd number in between. Cool, very cool. We okay? Do you wanna do one more homework problem? Or would you rather look at some force and work problem? I don't care. We have 5 minutes, we don't wanna waste it. Benji? He's thinking about what he wants.
Are we gonna need, on the homework, the first question had the midpoint rule, are we gonna need that?
It's the same, right? You just go in the
Yeah,
middle.
it's the same.
Okay.
Can you, would you be able to tell us like what formulas won't be like on the formula sheet? That way that we would know like, okay.
This is it. If I ask you to do trapezoids, this will be there.
Okay.
That's the only formulas come for free at the test. So yes, you need to know your volume formulas, you need to know your arc length formula, you need to know your surface area formula. You need to know areas top minus bottom or right minus left.
The parabola won't be there.
Oh, if I ask Simpson, this will be there.
Okay, okay.
I won't put both there and make you choose. It's like if I say do Simpson, I'll give you the right formula. If I say do trapezoids, I'll give you the right formula. It's just all in one place so you can find it. Because the homework has some of each, right? Good questions. That's a good question. We should do a problem. We should not waste time.
Can we do a force work problem?
Sure. Let me find the homework again. Are they getting better?
The force work problem?
Yeah.
Mm-hmm.
Are you happy there were videos?
Yes.
Man, this is the one section where like, how many videos can we put in here? We can't put in every one, right? You have to struggle sometimes, like, okay, I got it. It's like, almost. Let me look at the tutorial. Oh yeah, I had everything right except this one piece. So that struggling is when you're actually learning how to do it. I have one kid in my Cap 1 and keeps thinking he'll just look at the calculus. Did not pass test 1. Just looked at it though. Looked at it a lot. I'm gonna look at the cone. Where's the cone? There's a cylinder. It's the box. The box looks really hard, yeah? Oops, sorry. Let me plug in. I'm whizzing through the homework without showing you. Come on. It looks really hard, yeah? And then the integral is really elementary. It's kind of hilarious. It's like, what? I was working really hard. Why did it turn out? Because what does slices look like? Rectangles. And you know what the rectangle is. It's 8 by 4, all of them, right? 32 times thickness is the volume of the slice. You just have to figure out where the slice is going and how many slices you're adding up. So it looks really fierce, but it's not. Do you notice I've been training your brain to look at things? Because that's actually how you build these intervals that are applications. And that's what they do in physics all day long. There's the swimming pool. There's the storage tank. I thought there was a cone in here. There it is. Oh, but it has a video. Never mind. It has a video. Which one is it that you're worried about?
I couldn't figure out
We
that.
did the milkshake in class yesterday. You'll have to get somebody soon.
I see.
It's really great. Still don't know what color that is. No?
Well, I mean, that one has a video.
You want to see it anyway? Okay. We got an inverted circular cone. What does that mean?
It's
The kind you expect. Real cones go the way. Actually, cones go both directions. That's the actual cone in space. And that's something about cosmology, the shape of the universe. Some of it is conical. Height 12 and base radius 4. Filled to a height of 11. Okay. That's all I really need. Where did they all go? There we go. Height 12. Base radius 4. Filled to 11. Come on. Give me my data. Density of water is 100, yeah. Okay, this came from the book. That's why it says, the density of water is 1,000 kilograms per meter cubed, but G is 90.8 meters per second squared. So the density on the test is 9,800 newtons per meter cubed. I'm gonna empty the tank, pump to the top. Okay. If somebody starts talking to you about gravity, they're just saying, I gave you the wrong kind of density. I gave you mass density and you want weight density because you want force. I won't do that on the test. That's just distracting. Do you agree? It's distracting. That's all it is. Okay, so work. So you can set it up and then go and fix it up. Don't think I have to get it all down. What are some pieces that are definitely in the integral?
dy.
dy. What else is definitely in the integral? The 9,800, yes. And these are part of the weight. It's part. I have something that goes over here. And then have distance. And I have to figure out some limits. So you don't, when I grade it, I see your integral. I don't see all the thinking and what order it was in. Just grab the pieces you know and then fill in the harder pieces later. So you need a slice. And it's going up to the top. I'm going to put the y-axis in. And this is the origin, then this is a height y. So how far does the slice go?
Y to 12.
From y to 12, so how long is that?
12 minus 12.
Top minus bottom. And what are the limits? We'll get the hardest piece left. 0 to 11. So the limits are not always the same. If they're full, the limits in this are the same, but if it's not full, it's a different amount. This is where the slices are. I don't pump anything over here, so that's why the integral isn't over there. I only pump this stuff. And then you gotta figure out what goes here. What's the area of this thing?
Pi squared.
Pi r squared, okay? And that would be great, and you could leave yourself a note, say, fix this. And go do the rest of the test. I gotta think about R, and then you'll be working the other part of the test, and you go, aha! What is the aha for getting R? Similar triangles. Right? Because I see two triangles, the big one and the little one. And I wanna write the R in terms of Y. So that's what you need. R compares to Y as 4 compares to 12. So R is 4, 12 is 5. Better?
Mm-hmm.
Why does it look so easy when I ask the little questions? Because the questions are little. That's what you have to ask, is the little questions. And then suddenly it's like, wow, I got the whole thing. Yes, there's a square here. It said fifth.
Will we have to solve for this on the test?
You mean integrate?
Yeah.
Yeah, normally I just have you build these. You will integrate on the test, but once you've done this, to integrate that, it's not bad, right? I just have constant multiples, and I take my 1/3 y squared and multiply through by 12 minus y. It's actually a polynomial integral, so it's not a hard integral, but it's just time consuming, so it's not really what this test is really about, building all the models. And I like to write long tests. I'd rather have an extra question, and so that every question is worth less. Just be forewarned, okay? You need to plan to manage your time effectively. Some teachers just say, here's 4 questions, go. It's like, I couldn't even start this one. There's 25 points gone, and it's a C, if everything else is perfect. You know, so that's not me. The test draft exists. I will type it this weekend, and then I take it to make sure it's not too long for you, and make sure the numbers aren't quite so messy. They're a little bit messy. I like the numbers to play, but not where it's messy. And so I will have more intel for you on Monday. Monday is review day. You can cut. I can't recommend it. See you Monday.
Thank you.
Do lots of homework. Send me an email. Remind me to record your roundup one.
Thank you.
That was really perceptive. Every day, all the time. Go text, get in, I have a paper here.